So good afternoon, everybody. How was the day? Is long today, huh? So how was the test? Good? Easy?
So the time was pretty tight, sir.
Time is always tight. In life, time is always tight.
So, but can't you just give like only one submission and just have an hour-long paper?
We can, but do you know that submission of 20-30 pages on a PDF sheet is often very difficult. So all those take a lot of difficulty and time. You already saw that for submitting 3-4 pages, some students had problems. The
Yes,
uploading and all that causes huge difficulty.
but sir, in this case, we only have to upload once and like.
Yeah, have you ever done some 20-page submission?
Sir, I've done 10 to 12 page submission.
10 to 12 page won't work here. It will become longer. So it's a problem. We won't. So I will continue with this only. There are other reasons also. I'll let you know later.
Okay, sir.
Sir, in place of taking one PDF, you can take 2 or 3 PDFs, but only one. The submission will be done only once, so that
No, what is wrong here? Here you
because each time when we like in my case, I make the PDF in phone, then I have to send it through my mail, then I have to download from my laptop, and that
that's
takes a
all
lot
right.
of
But
time.
there was nobody who could not submit. Everybody submitted.
Yes, sir. That is fine.
That we did not. We made sure that anybody who had a problem, we took care of that. That is not an issue. Chalo. So let's continue. Somehow I cannot see the screen. Can you all see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Why am I having a problem seeing the screen? Let me do one thing. Just give me a moment. I'll sign out and sign in. Good. So last day we did this concept of propositional logic where we had Boolean variables and then we coded them as sentences and then we developed truth tables. We did examples like I am the president, I am well known, etc., etc. We coded them, then we converted them to truth tables, and we discussed 4 terms, namely validity, satisfiability, unsatisfiability, and non-validity. A formula is said to be valid if it is true for all interpretations, and a formula is said to be satisfiable if it is true for at least one interpretation. And an interpretation is an assignment of truth values to the Boolean variables. And once I assign an interpretation or truth values to the Boolean variables, invariably the formula becomes true or false. A formula which is true for all interpretations is said to be valid. And we saw several examples. Now you work out this example, please. All of you, please work out this example. So what would be my Boolean variables? A.
AMJD.
No, what is my Boolean variable? A, what would A be?
Arjun is thin.
Arjun is thin.
What would B be?
Mohit is not.
Mohit is bearded.
No, it is bearded. What would be C?
Julia is
Julius.
What would be D?
Devika is graceful.
Anything else? Any other variables or 4 variables are enough?
Enough.
4 are enough, sir.
What is F1? First sentence.
A implies not B or not C.
Everybody agrees?
Yes.
Yes.
What is F2?
C
C
implies
implies
D.
D.
F3?
D union B implies A.
Union. From where did union come?
So like and D and B.
Implies?
A.
A.
A and B.
What is my goal?
B.
Not C.
Not C.
Good. So this is how we do proposition
So there
logic.
is another statement also. Mohit is bearded.
There is another statement. So this is actually F2 is here, na? Where is the statement?
Sir, it will be F4.
Yes,
Last.
Yes, sir.
F4.
This, yeah.
F4B.
Correct, correct. F4 is B. Correct, correct. Good. Right? Clear, everybody?
Yes, sir.
Okay. Now we come to the statements that we had talked about the other day. That when we start writing statements where we cannot list out all elements, these issues cause problems in proposition logic modeling because we cannot list out this wherever. It could be infinite, and if it is infinite, then it is a problem. So in order to do that, we move to what is called predicate logic. In predicate logic, we add a few new things. Firstly, Boolean logic had only Boolean variables and connectors. We add the concept of variables. Why do we add the concept of variables? So that we can encode this wherever, some, etc. Then in addition to propositions, we extend the concept of a proposition to what is called a predicate symbol. A predicate symbol is a multi-argument proposition. If you consider a proposition which says in the first one, we would like to write a proposition goes x, y, where we says x goes to y. So this is a Boolean predicate. It is a Boolean relation. It takes values true and false. Can you guess what x and y would be?
Variables.
What? Variables. Very good. X and y are variables. So you can have multi-argument functions. Now, How do we model people like Mary, school, lamb? They are modeled as constants. So here, Mary, school, lamb. As a notation in our class, we will use capital letters to start with all constants. We will use small letters to start with propositions, predicates, and variables. And later on, we will see that like propositions with arguments become predicates, constants with arguments will become what? We will come to that at some point in time, that constants with arguments will become function symbols. Other than these, in addition to our normal connectors and or not, implies, etc., we introduced two new connectors. These connectors are also called quantifiers. One of them is called the there exist quantifier. The other is called the for all quantifier. And we will use them to quantify the variables. How will we use them to quantify the variables? So we will write this wherever Mary goes, so does the lamb. We will write for all x goes Mary x implies. Can anybody tell me what will I write?
Goes lamb x.
Lamb x.
Right. So the for all x says that for every x, if goes Mary x is true, then goes lamb x is also true for the same x. How will we write Mary goes to school? We'll write goes Mary school. This becomes my F1. This becomes my F2. And my goal becomes goes lamb school. And all I want to do again is to prove F1 and F2 implies G is a tautology. That means it is true under all interpretations. So to prove that it is true under all interpretations, my definition of interpretation will have to be enlarged, because I am now using new quantifiers, I am now using variables, I am now using predicate symbols, function symbols, etc. So this is how things will become more complicated, but the underlying principle is to prove that this statement is valid. My deduction will always be that my facts or my premises implying the goal is always true. If the premises are false, then everything is true anyway. It doesn't make sense. But it says that if the premises are true, then the derived deduction or the inference is also true. Take the second one. What will I write? What predicates will I have? In the second one, what predicates will I have?
Contractor x.
Correct. Contractor X.
Engineer x.
Engineer X.
Dependable x.
Good. Very good. How will I write no contractors are dependable?
For all X, negation of contractor X.
for all x, negation of contractor x. What will that mean? There is no concept of dependability here. If you write for all x, if you write for all x, negation of contractor x. Agree what you want to write?
Negation of contractor X and negation of dependable X.
For all x, negation of contractor x and negation of dependable x. Is this correct, others?
Yes.
No.
No, sir.
So for
No, sir.
all x, contractor
No,
x
first tell
implies
me
not.
why. If anybody has an objection, then tell me why it is wrong.
Sir, I think it states that X is never a contractor and X is never a dependable.
Right. Very good. Very good. This statement says that for everybody is not a contractor and not dependable. That's not what it says. It says that anybody who is a contractor is not dependable. It says no contractors are dependable. This is not what it says. This is not the correct answer.
Sir, contractor X
Correct.
implies
Contractor
not
X.
dependable X.
But what for all what will you write?
For
all x?
Yes, sir, for all X
Contractor x
implies not dependable X.
implies not dependable x. What about this? What about
Aren't
others
these two
saying?
similar?
Huh?
Aren't these two similar? Not of A and B is equal to A implies B.
Is that so? A implies B is not of A and not of B?
No, sir.
A implies not B. Is it the same as not of A and not of B?
So it is A implies B not equals to not A and B, I think. Or
Is that so?
so then what's the formula?
What's the formula? I will tell you. You know, you all have now found everything is internet. If nothing is there, look at Google or teacher will tell you. You have forgotten the basic premise. A implies B is not A or B. What is the truth table of A implies B? If A is false, B is true. If A is false, A implies B is. What is the truth table of A implies B? If you are now saying, sir, tell me then what is the answer?
Sir, it's true. Sir, it's true. False implies
Wait,
true
wait,
is
wait,
true.
wait, wait, wait. The way he is responding, then tell me what it is. What is this? This is not A and B or not A or B?
Sir, or B.
No, who asked that then that time?
Yes, sir, I only asked it.
So
Or
it
B.
is not or. So now is it clear to you?
Yes, sir.
Don't forget basic things. So anybody has a doubt on this one, that this is right or wrong? For all x, contractor x implies not dependable x. Is it okay, or anybody has a doubt? Does anybody have a doubt?
Sir, when are we going to write for all X, contractor X and dependable X or not dependable X? When would and symbol come in middle?
So you're asking what is the meaning of?
Yes.
What is the meaning of for all x?
contractor X
X
and not dependable X.
and we have written for all X, contractor X implies not dependable X, right?
Yes, sir.
Can anybody tell me what is the difference between these two? He has asked this question. Can anybody help?
Sir, first one tells that everyone should be a contractor and should not be dependable.
Correct. The second one says?
Second one says that if someone is a contractor, then he cannot be dependable.
Right. Have you
Got
understood
it.
now?
Yes. Yes, sir. Got it.
So the first one says that for all X, contractor X are not dependable X, and you can break it up and it will become like this. This is equivalent to for all X. It will be even more clear to you. And for all Y. Because it says every person is a contractor and not dependable. The second one says if you are a contractor, you are not dependable. So our statement was all contractors are not dependable. So this is the correct statement. This is a very important point. Everybody should note that this doubt is a very important point. Anybody whose this part is not clear? Good. How will you write it with there exists? What is the meaning of there exists? So how will I write?
Sir, can I write it like for there exists contractor X, then not dependable X?
No, that is what is supposed to be there. There is a person, there exists as there is somebody who is a contractor and not dependable. But that may
Some
mean
contractors are not dependable.
that is a different statement. There exists X, contractor X, and not dependable X is not the same as this statement. These two are not the same. This says that some contractor is not dependable. The other one says every contractor is not dependable. How will you write every contractor is not dependable?
So negation of
there exists
the
and
contractor and X is dependable.
Correct. So you'll write there exists X, contractor X, and dependable X. The negation of the whole thing, right? This is what you're saying?
Yes, sir.
That is, I am finding somebody who is a contractor and dependable. This finding somebody who is a contractor and dependable is not possible. Clear to everybody? Akash Tripathi, is it clear to you?
Yes, sir. Yes, sir.
Then what was the second statement we had?
Some engineers are contractor.
Okay, so how will you write some engineers are contractors?
There exists
contractor X and engineer X.
There exists X, engineer X, and contractor X. Is that clear to everybody? Anybody has a doubt on this? Some engineers are contractors?
Yes, sir. Sir, in this case, why it will not be the case that there exists X, engineer X implies contractor X?
Very good question. Another good question. So now he's saying compare this with the there exists X What is the difference between F1 and F2? We have understood the difference between G1 and G2. That we have understood. Now, what is the difference between F1 and F2? There exists X, engineer X, and contractor X. And there exists X, engineer X implies contractor X.
The
Sir, it
second
is not
statement,
symmetrical.
No, symmetrical is all right, but which one is right, which one is wrong? F1 is right, we all know. But his question is, why not this one?
the second statement also encompasses all contractors, even if they are not engineers.
It does not encompass anything about a contractor.
Like if that person is not an engineer and if he's a a
The
contractor.
first one also doesn't tell you anything about not an engineer. It just says there's somebody who is both an engineer and a contractor. The second, when will the first one be false and the second one be true?
So if engineer is false, engineer X is false, then the first one.
False. That means if there is no person who is an engineer. That means you are right. If engineer X is false for every X. If engineer X is false for every X, then F1 will be true or false.
There is no
False.
engineer, F1 will be false.
F1 will be false, but F2 will be true. Who asked this question? Is it now clear?
Yes, sir, I got it now.
So you have to be careful with your implies and your and for all and there is good. So now what we do is we now add these symbols and we write down our formulae. So for Mary, we write down F1 is for all X goes Mary X implies goes lamb X, goes Mary school, goes lamb school. Here my constants are, these are my constants. Mary lamb school are constants. X is a variable. Goes is a predicate, 2-argument predicate, and I have used for all. Similarly, the contractor example can be written as we just discussed, for all X, contractor X implies not dependable X. This implies cannot be written as AND. Then we wrote there exists X, engineer X and contractor X. That also cannot be written as implies. Therefore, some engineers are not dependable is also written as engineer X and not dependable X. There exists X, engineer X and not dependable X. We also see here again, we will turn out to prove this is valid. The proof of validity means true for all interpretations. And the concept of interpretations will become much more complicated as we proceed. Now let's do these ones. All of you, please do the first one. All dancers are graceful. Aisha is a student. Aisha is a dancer. Therefore, some student is graceful. Please do it. Okay, what would be my predicates?
Dancer X,
Dancer,
graceful X,
graceful.
Let me write short forms. Dancer X, graceful X,
Student X,
and constant.
Aisha.
Aisha is a constant. What is F1? Akula Vikram. Are you there? Akula Vikram. Are you there? Apurv Bansal. Are you there? Apurv Bansal. Are you there?
Yes, sir. Yes, sir. Yes, sir.
What would you write? F1?
So for all x, hello.
Yes, I'm hearing you.
Yeah.
For all X, then?
Dance. Just give me a minute, sir.
Bhave Veer Malik. Bhave Veer Malik. Vishwanath Haldar.
Yes, sir. For all x, dx
DX.
implies gx.
Good. Thank you. Chavi Chaudhary.
Yes, sir.
How would you write the second statement? Aisha is a student.
Sir, Aisha SX.
SA.
SA, sorry. Sir, F3 is also there.
Yes, sir. D.
What is F3?
Sir, D, A.
And what is the goal?
Sir, F1 and F2 and F3. Oh, sorry,
No,
sir.
no.
Sir, some student is graceful. S implies G. G of X.
Therefore,
Sir, there exist some X.
There exists X, then
SX
SX
implies GX.
implies GX.
GX.
Everybody agrees? Devjit?
No, sir.
Sir,
No,
F1
sir.
is
It should be and.
And
It should be and.
Devjit?
Yes, sir.
It should be?
Sir, I am also thinking the same only. Just let me.
Those who objected, please again come back and tell me what is your objection.
Sir,
Goal
the
should
same
be
thing.
in
SX
F1.
and GX.
Sir,
Chavi,
Yes, sir.
they are saying it should be SX and GX. You are saying it should be implies. Tell me which one it should be.
Sir, there when SX implies GX also says that there exist some students who are there exist some not students who are graceful, but they are not students. They are maybe dancers.
So what is correct? Is this goal correct? This with implies is correct or and is correct?
Sir, I think implies is correct.
You remember what we discussed just 5 minutes before this here? Some engineers are contractors, and we said F1 was right and F2 was wrong.
Yes, sir.
Isn't it the same thing? Some engineers are contractors. Some students are graceful.
Oh, sir, I got it.
Devjit?
Sorry, sir.
Yes, sir. It's the same thing. It should be false. So for the false case, it will be and because of the false.
And here again, we want F1 and F2 and F3 implies G to be a valid statement. So all of you do the next one. Jagdeep Vemulapalli, are you there? Jagdeep? Jagdeep Vemulapalli, are you there? Jyotirmay Singh? Jyotirmay Singh?
Yes, sir, I'm here.
What would be my predicates in this passenger wala example? Jyotirmay Singh, what would be my predicates?
I'm a little bit confused, sir.
Did you understand the previous one? Did you
Yes.
understand the previous two ones?
Yes, sir.
Then what is your confusion here? Did you understand here why the predicates are dancer, graceful, student?
Yes, sir. Here.
If you don't try and your answer is I'm confused, then you will not learn anything. You're not concentrating.
One is PX for passengers.
Passenger X, then?
One for first class and second class.
First class X, second class X.
And one for wealthy and non-wealthy.
Wealthy. Any others? Anybody else? Any other predicate? Any constants? How would you write the first one, F1?
Sir, for all x, passenger x implies negation of f of x intersection and s of x or negation of x of x and f of x.
You're taking exclusive OR, is it?
Yes, sir.
So you want to write it is exclusive OR of first class and second class, right?
Yes, sir.
So how do you write exclusive OR is?
Negation of f of x and s of x or negation of s of x and f of x.
XOR. Is everybody okay with this? This is exclusive OR. Anybody has a doubt? Himadri Pandya? Himadri Pandya?
Professor, I just wanted to ask, since there are only two categories, first class and second class, can't we define second class as a negation of first class?
Since they didn't tell us that there are only two categories, we don't know. Do you remember in older trains there used to be interclass, third class, AC 2-tier, nowadays AC 3-tier, chair car?
Yes, sir, but I thought in this example, since only two are mentioned, so.
Yeah, it is not necessary. Otherwise, that is an assumption. We need not make that assumption here.
So we can make that conclusion from the statement F1 means. Otherwise, you cannot say that Fx is negation of Sx.
It is not given to you. So it is whatever is written automatically will come. Because the train may have other classes. The train may have vegetable class, vendor class, engine, bogie, trailer. We don't know. It only talks about passengers being in first class or second class. Animals could be in another class. So first class implies negate of second class may not be true. It is only with respect to passengers. What is F2? Sai Subhash? Sai Subhash?
Yes, sir.
What is F2? If you do
For
it
all
in
X,
class, you don't have to study hard. Tell me what? For all X?
P of X implies
P of X implies
S of X implies S of X implies not of WX.
That's all.
Intersection
And intersection
and negation of WX implies S of X.
Very good. Clear to everybody? If and only if. Tell Lambu, Khushi Reddy, is it okay?
Sir, I think I have wrote it in another way, sir.
How did you write?
For all X, P of X and S of X. Sorry. For all X, P of X and negation of W of X implies P of X and S of X.
You have written, let me write down. For all X.
For all X, P of X and negation of W of X.
All in a single bracket, right?
Which implies P of
this
X
whole
and
thing. This whole thing implies.
Yes, sir.
What?
P of X and S of X.
So it says that if somebody is a passenger and not wealthy, implies that person is a passenger. There is no use of writing that. And in the second class. All right.
Yes, sir.
Now,
sir.
So
in the F2, the first statement you wrote, F2, where the end statement is like negation of WX implies SS.
Have you read this statement, Prabha? If and only if?
Yes, sir.
What does if and only if mean? What does A, if and only if B mean?
Sir, A is valid if and only B is valid.
A implies B and B. You have forgotten all your proofs. The if and only if proofs that you did in math. You have to prove this side implies that side and that side implies this side, है ना?
Okay, got it.
Remember?
Thanks.
If and only if is the two-way proof, na?
Yes, sir.
So now tell me here. Firstly, Kushi Reddy, you did not get both way implication. Number one. All right.
Sir.
Secondly, if you have written px and not of wx, this px is not necessary. Is it necessary? The second px?
Yes, sir. It's not necessary.
It's not necessary. Okay. So that part is also clear. Now, tell me, if this was only the if condition, then you are saying that if somebody is now, if all passengers, you are saying if somebody is a passenger and not wealthy, implies this person goes to second class.
Yes, sir.
And what about the other side? How would you write?
We should cover the case that the first one is also which should be true, right, sir?
In your theory, you will write passenger and second class implies
not wealthy X.
And you will add these two up, right? This is what
Yes,
you will
sir.
do.
Yes, sir.
Now tell me, anybody else tell me, this is one option he has given for F2. What is the difference between this F2 and this F2?
So if someone is not a passenger, this will result in true. Acha, but that one. Okay, sorry.
That will also result in true. This will result in true, that will result in true. Are these two identical or is there a difference?
Sir, if he is not a passenger and he is in second class, then it will give true always.
If he is passenger and
if he is not a passenger and he is in second class.
If it is not a passenger anyway, it is supposed to give true, no?
Sir, if somebody is in second class, then it will be different. Then it will be different.
Now, what will be the difference? If somebody is in second
somebody
class,
is in not in second class. Sorry, somebody is in not in second class, then statement will be true. No.
So all of you will think about this. Please note this down and think about this and tell me whether they are identical or not.
So somebody not in second class and somebody wealthy, then there will be difference.
Somebody not in second class and somebody wealthy.
Yes, sir. There will be difference in F2 of these two different versions.
Tell me more details. Tell me where the first one and the second one will differ.
In first one there will be a passenger, so it will be true to false, and here it will be so the F2 first version of F2 will be true and second version will be false.
For what case? For what case?
Somebody is in like second class and no, somebody not in second class and somebody wealthy.
So you're saying that somebody is not in second class,
yes,
but wealthy.
Yes, sir.
So if somebody is not in second class, then this part will be true or false. This part is false.
Yes.
And this part is also false.
Yes.
So the whole statement will become false.
Yes.
And here somebody is wealthy, so this will become false.
Yes.
So this will become true, and somebody not in second class. Very good.
Yes.
Has everybody understood this? Has everybody understood this? This is very critical to understand. If you don't pay attention, then you won't understand something very important which he has pointed out. Who did not understand, tell me. Malga, Kaushik, have you understood?
Yes, sir, like thinking about it.
So the first statement, if I find there is somebody who is not in the second class and is wealthy. That is my situation. The opposite of what I wanted. Then the F2, the first one, will become false or true. What will the first one become, true or false? Because it's not in second class, the left hand side will become true, and because it is wealthy, again no, this will become true, no? F2 will become true or false?
So if Px is true, then it will become false.
The Px is true is known. Okay. There is a passenger. There is a passenger. Who is in second class and wealthy. This statement will become true or false. There is a passenger who is in the second class and wealthy.
So true. First F2 will be true.
Sir, for someone who is not in second class and not wealthy, then?
Sir, it will be true, I think.
So what does my statement tell me? My statement tells me the passenger is in second class if and only if the passenger is not wealthy. So if the passenger is not wealthy, then he's in the second class. If the passenger is in the second class, then the passenger is not wealthy. Okay. Now, for the case when the passenger is neither in the second class but is wealthy, what will happen?
So both are true.
Both are true.
The right side is true.
No, in F2 dash, the second one, passenger is true. All right. So here the left side of F2 dash will be true in the first case, because the passenger is wealthy, it will become false. And the passenger is not in second class, it will become false. So this statement will also become true. So are these two identical or are these two different? Think about it very carefully and let me know next day.
Sir, they are identical, right? We can tell it.
Come back and say, Harsh Makhwana, you had pointed it out, right?
Yes, sir, I'm thinking now.
Okay. So tell us tomorrow whether this is true or not. Okay, we'll stop. You can stop the recording. We'll continue tomorrow.